Gases will diffuse and effuse a lot too. So let's talk about what that means. Remember, gases are really hard to contain unless your container is like perfect, which is like never basically. But anyway, diffusion, if you hear that term, is when two gases mix together. Different gases will mix through some kind of like hole, and you end up having gas 1 in gas two's area, and gas 2 contaminates and goes into gas 1's area. Effusion is the movement of one gas through like a small hole into a vacuum. And sometimes this kind of concept is important too. So diffusion is just the mixing of gases together, and effusion is when you have a gas that goes through a small hole into a vacuum. And we'll talk about these coming up and talk about what makes them go faster in diffusion or slower diffusion, and it'll also apply to effusion as well. Graham's law is a relationship that talks about how to figure out how fast or what the rate will be of effusion and diffusion. And what essentially Graham found out is that the rates, the speeds that these things will diffuse and effuse is inversely related to the molar mass. All right. And so what this means is that the lighter molar masses, helium and hydrogen, things like that, are going to effuse and diffuse a lot faster. On the other hand, the bigger molar masses, SF6, bromine, stuff like that, big molar masses will effuse very small. So that's basically what it is. And you can actually calculate the differences in rates if you want using that thing. We won't do that too much, but it is something you can do. So Graham's law basically says that as the molar mass gets bigger, the speed of those molecules diffusing and effusing is going to get smaller. And you can imagine that makes sense because the bigger gases will be bigger. They'll have more volume, and maybe they don't fit through the little holes quite as easy, so it takes them a little bit longer. On the other hand, the small gases fit through small holes, no problem. They can go through a lot quicker. This is kind of a fun experiment. This is a YouTube, and it's not the fun YouTube website where you watch cat videos and stuff like that, but this is a true YouTube. It's in a U shape right there. And on the left-hand side, we have ammonia, and on the right-hand side, we have hydrochloric acid. Now, NH3 ammonia has a molar mass roughly 17 grams per mole, and hydrochloric acid on the right there has a molar mass that's about 36.5 grams per mole. And when HCl and NH3, which are both colorless gases in their gas form, by the way, when they come together, they will make ammonium chloride, which is a solid. So in this U-tube, there's like a little bit of a sponge, if you will, that's been soaked in ammonia on the left and hydrochloric acid on the right. And the gas vapors are escaping from both of those. And we're going to see that what's going to happen, the solid ammonium chloride is going to form on the hydrochloric acid side before it forms on the ammonia side, because ammonia is a smaller molar mass. So it's faster. It effuses and diffuses a lot faster than big, heavy HCl, 36.5. So this is a direct result of Graham's law. You can make predictions like this, which is cool.
On the right is HCl gas, and on the left is NH3 gas. Where the two meet, a reaction occurs producing ammonium chloride gas. The reaction occurs primarily on the right because NH3 is lighter and diffuses faster.
So NH3 would run, if you will, a lot faster up that U-tube and get to the other side before heavy HCl does. But when they mix, that's when you see the white solid. And the white solid in this case was only on the HCl side. HCl is a lot slower to diffuse and effuse than ammonia is. So that's why you see the white ammonium chloride only on the right and not on the left side.